this is a huge topic. That's going to be not too different from what we've seen, but it's going to be a little bit different. And I'm actually going to show you, right? We're going to do some examples. And I'm going to show you two methods for each. And you don't need to do two methods every time when you're doing a problem. You just need to decide which one you like better, right? And stick with it. Okay, so here is the problem. Okay, that's the problem. We're going to multiply this times this. Okay, now method number one is I simply just use the distributive property and I use it twice. So for example, here I'm going to distribute, so I'm going to multiply this times this, right? That's first. And then I'm going to take this same and I'm going to distribute it here. That's second. Okay, so 3n times 2n, so 3 times 2 is 6, and n times n is n squared. Second, I'm going to do 3n times negative 4. So positive times negative is negative. 3 times 4 is 12. This is 3n. Now there's not another n over here, so it's just n. Okay, so that's first this, then this. Now, so I distributed the 3n already. Now I'm going to distribute this. That's third and fourth. Always, always, always go in this order. Okay, 2 times 2, that's 4. This is 4n because it's 2 times 2n. And then fourth, 2 times negative 4, that's negative 8. And then I'm going to combine my like terms, which are here and here, right? This is not like terms because it has n squared. So I'm going to bring down 6n squared. I'm going to combine these. This is negative 12 plus 4. I have more negatives than positives. I have 8 more negatives, and then I'm bringing down negative 8, right? So I just brought this down, I just brought this down, and I combine these like terms, and this is my answer. Okay? So that totally works. You can just totally do that and never do this method, or I'm going to show you another method that you might be like, oh, I prefer that, and I'm going to do that every time. So here we go. It's called the box method. And if you've done Punnett squares in biology, it's kind of like that. Okay, so here's what I do. I'm going to take 3n plus 2 and put it across the top, and 2n minus 4 and put it across the side. Okay, and now I'm multiplying. So it's still the same deal, right? I'm still multiplying 3n times 2n, and I still get 6n squared. Then I'm doing 3n times negative 4, and I still get negative 12n. Okay, so you see it's actually the same math. It's just a matter of organizing it. Now I'm going to multiply this 2, right? So I'm going to do 2 times 2n. I still get 4n. And 2 times negative 4, and I still get negative 8. And then my like terms are pretty much always going to be in this little peanut shape right here, right? See that peanut shape? Okay, and then I'm combining. So I'm bringing down 6n squared. I'm combining these two. Negative 12 plus 4 is negative 8. That's negative 8n. And bringing down negative 8. So notice, same answer. In fact, even pretty much exactly the same steps, so it's just a matter of visual, which one do you like better. Okay, let's do another one. And in fact, look, I'm going to do kind of a special one here. Okay, looks like this. All right, ready? So this is example number 1. Here's example number 2. Okay, same deal. I can do this, right? 3w times 3w. So 3w times 3w, that's 9w squared. 3w times 1, that's 3w. Okay, then I'm multiplying. This is third and fourth. So I have negative 1 times 3w, that's negative 3w. And negative 1 times positive 1, negative times positive is negative. 1 times 1 is 1. Now, watch what happens when I combine like terms here, something kind of interesting. 3 minus 3, that's just 0. So this actually just ends up, when I combine my like terms, ends up just becoming this. Okay, and I can show you here. You're going to see it's the same. I'm doing the same stuff. It's just a matter of the visual. So I'm going to put 3w minus 1 and 3w plus 1, right? I'm still doing 3w times 3w. I get 9w squared. 3w times negative 1, right? 3w times positive 1, and then 1 times negative 1. And you can see, once again, when I combine in my peanut, my like terms, I end up with 0 here. And I get this. Okay? Again, this is the same. You get to choose like which visual you like better, if you like to just kind of do it all in line, or if you like to draw yourself the box. Okay? Let's do one more example, and then I think you'll be ready to get at it in IXL. Okay? Here, this last example is even just a little bit different. So let's do, this is 5a plus 3 squared. What does that mean? Look, don't be afraid of this. You know what squared means. It means something is being multiplied by itself. That just means this. Okay, this is not different. This isn't different at all. Okay, and in fact, let's go ahead and actually let's do the box method. This is called the box method over here. Let's do the box method first this time. Okay, we know that it's the same thing, but we've done the other way first. Let's see if we can do it this way first. You might decide, oh, I like it better. Okay, 5 times 5 is 25. This is a times a is a squared. 5a times 3 is 15a. And look, 5a times 3 is 15a. Those are the same. And 3 times 3 is 9. So now, let's combine like terms. Okay, now look, something interesting happened up here. Remember, this was 3w minus 3w. 3 minus 3 was 0. Those canceled. These do not cancel. This is not 15 minus 15. This is just 15 plus 15. Okay, so those aren't going to cancel. Look, this is 25a squared. 15 plus 15 is 30. That's 30a plus 9. Okay, again, I can do the same thing here, right? This is 5a times 5a. That's 25a squared. 5a times 3, that's 15a. 3 times 5a, that's 15a. And 3 times 3, that's 9. When I combine my like terms, I'm bringing down 25a squared. 15 plus 15 is 30, bringing down 9. Okay, again, same answer, just different methods. You can decide which one kind of clicks for you a little bit better.